Hey everyone. Um, Maybe we can do another quick raise of hands to get a sense of if we should wait a couple of minutes longer or if we can already get started. Okay, I'll wait maybe a couple of minutes more. Ja, doe maar. So maybe I can already kind of summarize what we've done before lunch. So we started with a very basic um, explanation on what is openEO, what is CDSC, and how can these two work together as individual concepts. And we saw some very basic, very simple workflows to start, which entailed accessing and downloading standard Sentinel-2, Sentinel-1 data. Then we already ramped up the difficulty a bit, code-wise, and how can I do proper cloud masking? We saw this in one community example. What if we don't want to download raw data? We want to limit the amount of data which we actually want to process. And then we want to use cloud masking. This is something we can do with the scene classification layer of Sentinel-2 satellites, which inform us on what are cloud shadows, what are clouds on the images which we capture. So that was an added difficulty. And then we added on some complexity to kind of showcase already the power of openEO on combining data cubes, loading data cubes from different backends, such as Microsoft Plenary Computer, but also showcasing increased complexity in processing, such as aggregate temporal composites. Now, what's the idea of this afternoon? Um, well, in the second session, we'll go for an exercise where you can hands-on work and just ask me questions whenever you run into something. And what the exercise will entail are a couple of basic building blocks, which we already covered in the sessions. And so the core idea will be that you yourself will create composites, aggregate composites around the capital of the country in which you're currently residing. Um, that's kind of step one. And if possible, in step two, we can even investigate how could we scale this up. So before we go into this exercise, I want to give a final example where we will simplify the openEO process on what we do, but I'll kind of showcase a tooling which we use in large projects such as World Ecosystem Extend Dynamics, World Serial, Crescent Watch, a tooling which we use for large-scale data extraction and large-scale model inference to create this world-based maps. So that's the idea. I'll go through this notebook for again, probably half an hour. And then afterwards, you can really get your hands dirty with a hands-on exercise. So prepare here. I'll get the relevant notebook open and let me already share my screen. Maybe before I go into the notebook, did anyone had some ideas or some unclarities they stumbled upon during lunch? They thought, hey, wait, I didn't fully capture at this point. Maybe I can ask again to explain it. Don't think I see any raised hands. So then I'll go ahead and I'll. Oh, yes, Vrijdag is on one hand. Go ahead. I saw a hand, but I don't hear anyone. Okay, then I'll go ahead. Um, so what we saw, what we did before, was some standard openEO processing. And for now, we were always limited to one spatial box, one area of interest on which we want to work. Um, now, openEO facilitates for you to easily scale up your experiment to go to larger areas to process at once. Now, for lightweight workflows, we perform all this processing on a cloud-based computational infrastructure, but also this infrastructure has its limitations. So we can't efficiently run a country-wide data extraction, let's say, or model inference necessarily in one openEO job. And for this, we created some tooling which allows us to track multiple openEO jobs. Because what are we going to see here today? Let's say, very specifically, we have the habitat workflow, and we now actually want to run this across our entire country. If in the case if it's Belgium, which is a small country, this isn't the most difficult task. But let's say you're from Australia or from Italy or France, well, then the country becomes much larger. And so the computational needs in order to run this workflow across that entire area also become larger. And then we can no longer do this from within a single openEO job because we'll simply go out of memory. Same happens with your own laptop, with your own BVPC. If you try to push it too far, the screen will freeze and you'll need to restart. And that's the same what happens in this cloud-based infrastructure. Your openEO jobs might fail because what we send in is too demanding. The system crashes and we get an error. So something we worked on quite a lot and is still in quite heavy development is something which we call our job manager or the multi-backend job manager. And on this, we also have a few community examples managing multiple large-scale jobs. And today, I'll discuss managing the first notebook with the same name as a folder. We also have a second one, which can also be nice and a nice inspiration to look into for your exercise. So let's discuss what we do. So imagine we tried our openEO job across a large extent, the entirety of Slovenia, for instance, and openEO goes into error. We get a weird error. You send us an email, say, hey, something is going wrong. We'll look into it and say, oh, you went out of memory. What do we then typically do? Well, then we use this job management tool, which is a Python client functionality. Now, the core ideas of this job manager is, well, you can launch multiple openEO jobs as a standard user at once. With your basic profile, you can run two jobs in parallel at once. However, if you have a large project and you need more support, you can contact us and we can, for instance, enable that you can run 5 up to 10 multiple jobs at the same time with openEO. And this will allow you to also perform your full-scale mapping much faster because we can run 5 openEO jobs in parallel, for instance. So what do I'm going to demonstrate in this fictive example? Well, I made some 10 by 10 kilometer boxes, which are a bit sparse. I'll simply visualize them here. So what do we then do? Well, we split up our area of interest in small individual boxes. And maybe to make it even more topical for Sonata, let's say we want to run this model inference. What we would do is we have a very large spatial extent. Our job goes into error while we investigate, can we now split this up in smaller boxes? And the sizes which we often use with openEO are either 20 by 20 kilometer tiles, but we try to push it as large as possible. So for some projects, we split up per S2 tile, but we also have been splitting up across UTM-based tiling, so 20 kilometer tiles. And what the job manager will do, well, in this case, we'll have 9 openEO jobs. The process graph will be identical. The only thing which will change is actually the area of interest. So we'll need to run these 9 jobs. And before we had this multi-backend job manager, it was up to the user to help create some kind of CSV file to keep track of their actual jobs, which were successful, which failed, and so forth. So this wasn't a workable solution. And that's why we created a tooling which will perform the tracking of these jobs for you. So what I did so far is I created a pandas database, pandas data frame, which contains my spatial extent. And this is the input which a job manager needs. So in this case, I'll send in an openEO job, and my only varying parameter is my spatial extent. So I list this in a pandas data frame. And we'll use this pandas data frame now we'll send it into the multi-backend job manager, and this will be used as a basis to track our 9 individual openEO jobs. But we'll see that later on. So, of course, we need to tell openEO what to do. What is it that we actually expect? So the multi-backend job manager takes 2 inputs. It takes this Panda data frame, which contains our variable input parameter, and it takes in the openEO process graph, which we still need to create. And this is done by defining, in this case, a star job function. What does this do? Well, it reads a row of my pandas data frame, exactly this row with my variable parameter, and it uses that input to do its calculation. So you'll see, I say, hey, the spatial extent is my input parameter. There we go. And then you'll see some code which is very familiar, which you've seen before. I load my SCL layer. I create a cloud mask. I use this mask to get my masked Sentinel-2 data. And then I'll do an aggregate temporal period. For each month, I'll take the mean value, and I'll do some interpolation. So what do I expect to get out of this job? Well, for each of these, I'll calculate, 9 batches of 9 3-dimensional output cubes, 4-dimensional output cubes, which contain, in this case, 3 temporal time steps, because I have 3 months and I'm doing an aggregate temporal period per month. It will have 3 time steps, and it will have, 3 bands. And the bands will be the mean value across my time for BO2, BO3, and BO4. So I'll create composites, monthly composites. So let's define now this as my openEO job. So we created this star job functionality. We created our pandas data frame which contains our variable input parameters. And then I think the only thing we need to do is create our job manager. We connect to our backend of choice. We add this backend to our job manager, and then we say run jobs. We will provide our two input variables, being our start job and this job data frame with my variable input parameters. And then I specify where to write the output. In this case, I use a very simple CSV file. So let's see what happens. So upon running it, you see in my repository, the CSV file was created. And what does it now contain? This is a tracking file which allows you to keep track of all various openEO jobs. And it gets updated every 30 seconds. I'll make it nice. I'll give it a nice view and align it. It contains a list of all, kind of a copy of all the spatial variables which I defined in my starting point, my job data frame. And openEO will add additional information to it. It will add a job ID of openEO jobs which it created and it launched. It will give us a status of all the different openEO jobs and add some additional interesting information. For instance, when did the job start running? What was the eventual usage of memory and how much credits did it cost? And you can even tailor this database to your own liking on how it looks and how it works. And now I've set the max to 2 parallel jobs because this is the standard setting for a standard user. So on max, 2 openEO jobs will be running at the same time. Now, we can take a look and see if we can get an updated version now. Let's take a look. And we see now, we waited again, 2 openEO jobs have been sent in. This is the standard max for a user. They've both been sent into our cloud compute facility and they're now queued. And so once they go to running, the CSV file will get updated again and we'll track its status here and we'll see, okay, they started running. And in this way, we can use a very easy CSV file for actually keeping track of as many openEO jobs as you want. Now, if I jump to the community examples, because I won't let this cell finalize, because it will take some time. What will the output be? Well, again, I calculated this composites. Yeah, here again, you see this 10-kilometer spacing, which wasn't, which is a bit different, of course, in the grid I initially created, but you'll download the data. It will actually automatically download for you the data, which contains the Verhaert files of our liking. Now, this looks like a very simple tool, but it's exactly this tooling which we use for scaling up projects. So if you want to extract, for instance, training data points across the entire globe, what we often do is we create an openEO job per S2 tile or per 20 by 20 kilometer box. And then we make use of this openEO multi-backend job manager, which gives us an easy interface as a user to keep track of our different openEO jobs. And then if we let all the jobs complete and let them run, I think we can see that in the, and we let them all run, then we can also, and I think I have an example here somewhere, we add in also the cost information and so forth, which can also be useful if you need to monitor your credit usage over your openEO jobs in order to keep the total cost as low as possible. So this was the last bit of tooling and actual openEO code, which I want to show before launching off a longer hands-on session where you'll get to play with openEO yourself, and have me here around in order to help you whenever you run into something. Are there any questions around the multi-backend job manager before we go into the hands-on exercise? I don't see any immediate questions, so then I'll introduce the exercise where you're motivated on working hands-on, and I'll do a regular check-in every 15 minutes to see, okay, does anyone need any help or any support? And the idea is really to help you get onboarded on how to use openEO. What is the exercise? Well, you've seen in the community notebooks, there are quite a lot of examples on, on accessing data, on calculating composites, okay, calculating NDVI as an openEO process, and we want to combine this. So the first step of this exercise would be, and I'll also post this in the chat, is to create an area of interest, so a 5 by 5 kilometer box around your capital of your country or any country you're interested in, maybe your last holiday location, and write an openEO process graph that loads in the Sentinel-2 data over a full year, calculates the NDVI, and then creates composites, aggregate temporal composites by month of the NDVI, and to run that openEO job. So that would be step 1. And then step 2, if we get there, we want to see, can we now introduce this workflow as well in this concept of the multi-backend job manager? And can we run all our jobs at once? So then everyone shares their boxes of interest. We create a data frame and we can showcase with the multi-backend job manager how can we now manage all these different jobs as a single user and keep track of all of them. So I'll write down the exercise here in the chat. I kind of like the idea of your last holiday destination. So step 1 is define a 5 kilometer box around your last holiday destination. Step 2 is create a process graph which extracts Sentinel-2 data. Step 3 is fetch the NDVI process. Step 4 is calculate monthly temporal Verhaert. 5 dividend as creatives and execute your job. Okay, so then let's remain in the call. You can already start, and I'll keep an eye on the screen. If you run into anything, just raise your hand. I think whatever issues you face will be interesting for the larger crowd as well. I'll also share once more the link to the community examples in Python. I think this is the best resource for finding some reusable code, which you can copy paste to your liking. And an additional nice resource is the Copernicus web browser, because you can use this web browser to also find the lat-long coordinates of which you need to define your processing box of 5 kilometers. The best or the easiest format to work in if you really want a specific box of 5 kilometers is UTM coordinate system. Is this exercise a bit clear to everyone, or are there any questions?
Could you repeat just good. About how to create that 5 kilometer square?
Yeah, so what I usually do is I go to the, oh, I'm not sharing my screen anymore. Oops. Yes, so I'll go to my last holiday location. I went to a holiday in the Netherlands. I think it was here where I was on holiday. So let's hover here with my mouse. If I go here, in the bottom corner, you can see the lat-long coordinates. What I usually do is simply write them down and then convert them to UTM coordinates. openEO, by the way, also accepts lat-long. So in the first test, what you can also do is you can simply not focus too much on the 5 kilometer box, but you could simply say, okay, I'm going to take a very small box around the city center. So I know this is my top left corner. This is the right corner. You see the coordinates changing. And then you can define this bounding box in lat-long coordinates as well. And usually, if you go to 3 digits after the comma, it's sufficiently accurate. So my tool which I often use for it is the web browser. And you can even in the web browser draw an actual box. Oops. Actual box as well. And then I think you should be able to get some information on this box here as well. If I copy it over, where is it? Let's see where, yeah. So I copied this information over, and actually the web browser now creates a polygon, which you can also use in openEO. But you see here, you get kind of the coordinates of the various vertices which I put there in the web browser. So my tool is often going here, getting the coordinates in lat-long, maybe using some package to transform them to UTM, or simply working from lat-long coordinates. That's also fine. Then I think I also got a second good question by Megan. Should we use mean, median, or max in DVI? Let's maybe go for median and DVI. So I'll change my exercise step 4 to also make it median. Any other questions? Then I wish you already happy programming, and I'll keep tabs on the chat. I'll also keep my audio on. So just whenever you need help, raise your hand or simply ask, and I'll respond. So maybe as a hidden step one, did everyone manage to create a CDSC account and go to the first step with openEO being the authentication? Did they manage to connect to the backend, or is anyone running into an issue there? Is anyone already past this step and working on their workflow? Maybe then raise your hand if so. I don't see a lot of hands. Is then everyone stuck on creating an openEO account? Authorization is taking a long time. Megan, if you run into something, feel free to also share your screen in the call. We can take a look with alongside with you to figure out what's going on. Or is it taking a long time to create your account?
I've created the account, but yeah, I'm just sort of running that connection line in the block and getting a very long process for the authorization, and then it's sort of timed out at one point. So I'm just trying again now.
Oh, if you get a link in this message, you need to click the link because the authorization actually waits until you click the link and then log in into the browser.
Okay, good that you mentioned that. Yeah,
yeah. So if you were logged out, what actually happens is that you create a cookie, and then the system remembers, okay, this person has now logged in, and it remembers your details. So if you simply run it, it will indeed go in timeout. You need to click the link and then log in with your CDSC account, and then openEO knows who you are on the CDSC backend.
Perfect, that worked. It's now authorized. Thank you.
Yeah, perfect. It can also be that anyone ran into some issues with, for instance, if you want to GitHub to get community notebooks and to download them. Not sure if everyone found their way there to GitHub and knows how to do it. So anyone else running into any issues? So I also see some late joiners here. So now we're by the way in the practical part of the session today. If you visit the meeting chat, you see the list of the exercise of today. If this goes well, we can add in an additional part to this exercise. The main idea is that you use the shared link of the Copernicus data browser to find coordinates of roughly a 5-kilometer box around your last holiday destination. Copernicus web browser gives this in lat.long. You can use this in openEO, that's perfectly fine. If you want it more accurate and exactly 5-kilometer box, then you can convert it to a UTM box, so in UTM coordinates. Then the idea is to authenticate with openEO and to create a processing pipeline where you load in the Sentinel-2 data, you perform the proper masking, so cloud masking. After you've cloud masked your Sentinel-2 data, you can try to perform the NDVI process, and from that data set, calculate monthly temporal aggregates, save them as geotiffs, and launch the openEO job. So in this part, you can work hands-on, and I think 10 past 2, I'll query a bit for a status update of everyone to see how far they've come. So, quick check-in. Could we raise hands if you're making progress on openEO authentication? And if you manage to, for instance, define a box of your liking. Good. I see at least 2 active participants here. Anything you're running into still, Megan or Maxime?
I'm just working on the NDVI at the moment. I guess it's step 3.
Okay, great. Now, definitely browse this community example. There should be, I think, a couple of community examples which actually use the NDVI process, which is already defined within openEO. So you should be able to couple it onto it easily. And then if not, it will make an interesting exercise to go through together.
Yeah, actually, I would suggest maybe that we do it together. Like, I'm quite aware that people here probably understand the concept of the platform, and several of us are already using Google Earth Engine. But just getting all the functions and everything is not the same, and the community like webpage you provided is very long and like so many things. So I don't.
Yeah.
It just
so
it takes a lot of time to see to try. So I think it would be.
I understand your perspective, but so this exercise is really tailored to see. Let's say you want to get started yourself with openEO. How can you do this? And you have a couple of resources where there's quite a lot of information. And I'm actually here to assist you when you run into something. So it's really tailored for everyone to get some dirt under the nails, run into some issues. That also gives us a nice perspective on where to further on improve. And then once we have some progress and people went through it personally, we can also do can take a mutual look on how it was done and how it was established. So the idea is to first do it a bit individual and then we come together again.
Yeah, but I think that people here will not be easy to saying that they are having like troubles at the moment because not sure what they should do and how to do it. At least for me, now I decided.
Okay, so what's unclear for you? What's unclear for you about the exercise? And on which do you need more information?
So it's, for example, I don't know where to find this create graph. I know what it is, I know how it looks like, but now I should go through all the documentation to find some things that you showed previously, and we were not able to follow up because you were just like showing. I suggest that we do it all together. You doing live coding, and then people can ask in between questions. Hey, I want to know this.
What are you not able to find? I'm here to answer.
For example, you said create a process graph which extracts Sentinel-2 data. Where is that graph that you were showing like links and connections?
So this is an interesting question. So let's discuss it. Process graph is terminology in how do we now actually, sorry, can I first answer the question? And then I can answer your follow-up.
This is like a question I would have.
Process graph. Yeah, let's touch upon that after this first answer. So what's actually a process graph? Or what do we call a process graph in openEO? It's a start to end definition of an openEO job. So a process graph, in all the examples which we've seen, would be something like this, where you first define where you have your collection. You say, well, I'll load in my collection the data in which I'm interested over the spatial box of the small box around your last holiday location, a temporal extent, and then we can add operations onto it. We can add this masking operation, this eigen template, and so forth. And all this together is what we call a process graph. Now, if you think back on a couple of other examples which I went through, for instance, in this Getting Started notebook, here we had a very simple process graph, where we only started with we make a connection. Whoops, there we go. And then let's see here. This is a very long list. We need to scroll through.
Just the catch. This looks quite long and difficult to grasp at this very moment. So
yeah, so in the
simplify a little bit.
In the notebook, if you go to the community example page, which I shared with you, there it's much shorter. So that's because I here actually ran the actual cells for getting more information on what data is available and what processes are available. But here in the community example notebook, it's really short. So what's the process graph? We get the data in which we're interested. In this case, we defined an operation which we wanted to do here. It's EVI, for which we don't have a standard process. However, we also link to the standard openEO process and EVI. So you can browse some and get some information here. Here, instead of calculating temporal aggregates, we only take the max time, and then we download it. And if we then take a look in the notebook, what do we now define as a process graph? It's you get your data, define some operations. Oops, take this max time. And now, before you actually download it or execute it, this is what we call the process graph. So the process graph is nothing more than your processing pipeline or your algorithmic definition of what you want to do on the backend. So if you want to get raw data, this first box can be your process graph. If you only, in this case, want to do EVI, then your process graph would contain these two boxes. And if you then also want to do some temporal aggregation, or in this case, get the max value across time, we add this third box. So all of these three are valid process graphs. And once you have it, you can attach, for instance, this download operation. And if you press download, then we actually launch the openEO job, and it gets started on the backend. So does this clarify then in the community examples? You have the getting started one. Here you have quite a lot of information on how can I set up in a very simple way. And if you then go to this managing large-scale jobs, for instance, a second one through which we went, here you can, for instance, get some more information on how can I perform my cloud masking, which I want to do, or how can I do temporal aggregation. So in these community examples, if you look a bit at all the, I think also at the documentation in the table provided here at the bottom, you should be able to find some nice notebooks which actually contain the operations in which we're interested. So the idea is that you browse this page and as a new entry user, try to explore how could I do this now with openEO. You still had, does this answer your first question? And I believe you still also had a second question.
It's just, I think that this way of presenting, like it takes hours for me to read than to go through all this documentation. I'm aware that I could manage to finish this exercise you posted in chat in a couple of hours because I'm not aware of all the functionalities of your browser. I'm just thinking that we're losing a bit of time doing it ourselves now, live. I believe that you should be doing that. We follow up and then maybe tomorrow ask questions about it more. Like going through the documentation, it's just like even this, I don't know, let me just check. Getting started, okay, I did that one. Then I have to go to load stack, to load Lancet stack to check something about jobs, then go to managing multiple large-scale jobs. Also, it just takes, I don't know, it will take me 2-3 hours. And then that's why you're not getting, I believe, I'm not sure if I'm correct, answers from other people, like how far are we with it?
Yeah, that can be a very valid opinion from your end. We actually hope to get you to actually start working on it. We've seen in previous workshop, if there's not an actual hands-on, that people just see the information and they don't interact with it, thereby lowering the amount of learning and lowering the uptake. That's why we motivate everyone. Hey, let's try to combine now concepts which we've seen in the Getting Started notebook and in the multi backend, mentioning multiple large-scale jobs, to combine them, because let's say in 3 weeks' time, you're in some project and you want to do something with openEO, then you wouldn't have the benefit of someone having nearby to help you with these first issues in which you might run into. And so now it's a very nice opportunity to try them out, to run into issues yourself, and then to share them with everyone else. For instance, the unclarity on how does this authorization works, it takes a long time. That's a very common thing which can happen, which we now ran into, and we could clarify within the group. And I think we strongly believe in that principle of doing the hands-on and then reflecting on it again. So from my side, I don't see it as a loss of time. I see it as a nice exercise on which we can come back together later on. And it's also part of a hands-on workshop, of course. But okay, we can naturally also agree to disagree. And I think in 15 minutes time, either way, we'll try to take a look at one of the examples someone has worked on and see if it's working.
Partially agree, but for example, now I ran something from the code from the community and I got job failed expectation batch job CDS E-J-2503, and it's a large number. Okay. Didn't finish successfully, status error. I don't think.
Nice. Can you share in the chat the job ID? So it can be that you as a user are working with openEO, you run into an issue, the job fails. What's nice then, if you have a contact, that we actually take a look live, why is the job failing? So I'll take a look and I'll come back to you once I see what's going wrong.
Okay.
Okay, so this is an interesting one. So I think you were using unsupported backscatter correction. So for now, for Sentinel-1, we only support sigma 0 epsilon. I can actually share it. I was taking a look at the job logs, and then we can take a look at the error. So gamma 0 terrain is currently not supported. Please use one of sigma 0 epsilon or gamma 0 epsilon when you're doing the SAR backscatter correction. So I think that's in your Sentinel-1 processing in the job which was launched. Yeah. And these messages, if you go to the Copernicus web browser, I'm now on a different platform where I can see also other ones' job. But if you go to the openEO web editor, let's go to the Copernicus data space. Yeah, my browser is complaining. Data space. Yes. So here, if you go to the documentation portal, we go to applications. Here will list all available applications within the CDSC. One useful application to get a better look into this error logs is this web editor, the openEO web editor. So I'll share this link in the chat as well. Oops. Oh, I see Lori also shared it. So if you go to the web editor and you log in, you can also see all your jobs which you have run. Here's an example of a couple of jobs which were finished. So one which is still in the created state and one which went into error. So then we want to know, okay, why did it go into error? If you then here press on the, I think on the information, no, on the bug, then you get all these debugging logs. Those are actually the ones I'm looking into right now as well. And then you can find one which has a level name error and see, okay, why did the batch job fail? In this case, it was because we're using the gamma 0 terrain instead of gamma 0 epsilon backscatter correction. But I think also for the exercise, normally we don't need Sentinel-1 now, because it's always a bit time intensive for computing. So we can only focus on Sentinel-2 processing for NDVI.
No, at this point, I was just checking something, just copy pasting from this community you showed, and this pops up. So, okay, like trying to learn by doing to check some things that goes on, but this is a bit too large to grasp in like 1 day, 2 day workshop online. Okay, thanks.
Oh, I see first process graph coming in. I first see a question for Megan. Hi Hans, not sure if I'm switching the wrong type in the JSON load command. Maybe the step is not even necessary. I think the step is indeed not necessary here. So this field JSON.load is, I think, here a dedicated step if you have indeed a polygon definition. But let me take a look at why it goes wrong, because you could in theory use it. Yeah, what I would personally do is avoid this step and simply use the coordinates of your polygon to define the bounding box. In the end, the bounding box only needs a north, east, west, south coordinate. So if you go to the web browser, you can get a rough idea of what the north coordinates is, the south coordinate, the west and the east coordinate, and I would simply write those down in the processing B box.
One question about those coordinates. You mentioned that we should use UTM coordinate system, and then when you show on how to use browser, you mentioned in the bottom right corner we see coordinates, and then you said that we should transfer coordinates in UTM coordinate system, but which coordinate system is this one? Because I think I just copy pasted these coordinates and I see the square that I want to see.
Okay, yeah, so maybe don't mind the UTM coordinates. So you can simply do it in langlot. I think it's fine. Yeah, I think it's a bit more specific for large scale workflows where, for instance, for machine learning operations, if you have a CNN network or whatever, it also always is trained on a very fixed input size, 100 by 100 pixels or so.
Mm-hmm.
And what we've seen is that lang-lot is not always as accurate as we would hope it to be. And it can be that instead of 100 by 100 pixels, we get 101 by 100 pixels. And that's why we then often go to UTM coordinates, which really go to pixel level and make it easier to correctly define the box we're interested in. But for the exercise here, indeed, we can simply use lang-lot. That's fine.
Okay, so UTM are not like standard geoinformatics way how to represent coordinate system. It's more like informatics way.
Yeah. So lang-lot is fine. Lang-lot is perfectly fine, I think, in this case.
Also, one question, because I saw that, for example, when we load, do you hear me, by the way? Yeah. Okay.
Yeah.
I saw when we load Sentinel-2 data that we have NDVI as already implemented method, and I saw also, for example, in your example, when you try to work with Landsat, that you also had NDVI as an already implemented method. So does it mean that in general, each data cube or each data collection has some set of specialized methods for itself? Because if I'm not from remote sensing, but if I understood well, NDVI could be derived for Sentinel-2, but not from Sentinel-1. So they have different methods like implemented.
Yeah, that's a very good, insightful question. So if I share my screen again, there we go. So to give the direct answer, in openEO, this is completely decoupled. So it's not that specific processes are linked to specific input data. What will happen if you try to combine operations which, for instance, don't interact well with the cube, is that you will get weird results or that you'll run into an error. For instance, I think NDVI needs specific input variables, so calculating it on Sentinel-1 data wouldn't make sense. But so what you can do is, if you have an openEO backend connection, so you have a connection, what you can do is you can browse these two separate entities. So you can browse what are my connections, and these are all the data sets through CDSC which you can access, and you can try to perform all these processes. Now go here. All this list of processes is decoupled of the input data cubes. So you can do apply on Sentinel-2, on Sentinel-1, on Sentinel-3, Sentinel-1, on whatever, on world cover. You can do NDVI, which let's browse it. NDVI. We can also run this on whatever input data cube, because you see, actually the process, the only thing it requires is an input data cube, and you can potentially give it additional arguments on which bench should I use.
Yeah, and what's the thing? I haven't passed any additional values for arguments, but in Sentinel-2, they're called like B4 and B8. So they're not called like near and red. And it works for my case. So it's probably, maybe then data are not correct. I mean, maybe results are incorrect.
This is actually a complexity which we want to take away with openEO, because if you work on different backends, if you work on Microsoft Planetary Computer, if you work on the Copernicus web browser, on the Copernicus data space ecosystem, if you would work on Microsoft Planetary Computer, you would see that for Lancet 2 data, all of them have a different definition in naming on how these bands exactly are called. And what we do is we try to take away for very basic operations this complexity for users by creating a mapping ourselves. So we know in the VI is something which is often done on, which is an operation which you do on Lancet 2 data. So for Lancet 2, we ourselves have made a mapping for the various backends which we support with openEO. If you call this process on a Sentinel-2 cube, it should use this and this input data. So in your case, it's done indeed automatically, and you don't need to define it. If we remember the example with load stack, I'll open it here. I can open it here in the browser maybe. What's happening? Not found. This is weird. Stack. Yes. If you here see with Lancet, this was something really experimental which we did. Here, this mapping didn't exist just yet. So we saw for Sentinel-2, we can simply call NDVI without a problem. But in this case, with this load stack, we hadn't made this mapping yet. It's very experimental. So here we said, well, instead of the near band, which doesn't exist, use this one. Instead of the red band, use this one. So you could do the same here, where you say, well, near equals p.8, I think, and red equals p.4. But it's not necessary for Sentinel-2 on Lancet data. But you can perfectly do it, and it should be able to pass as well.
Okay. So if one question in particular for Lancet 2 and Sentinel-2 notebook, if I understood you well, then in Lancet case, this is not exactly NDVI index because Lancet 2 doesn't have exactly near infrared channel, but it has something near. Okay.
Well, I'm not an expert on Lancet myself. I think this was just an example we want to show, where we try to find like, okay, could we make kind of a temporal timeline on some band mod, which we do on Lancet data and on Sentinel data. So we looked for compatible bands and to make a nice plot. So the load stack one was mainly to showcase, hey, we can even access some limited data on Microsoft Planetary Computer, and also to again show how you can use a built-in operation for NDVI calculation in openEO. I see a hand raised also by Payak. So I see you get an error. I think you're trying to log into Terrascope, so on which, while we were mainly working here and focusing on CDSC. So I'm wondering where does this come up? Because you're now using a different backend, which openEO also supports.
I'm not sure what you mean, because I'm just put the URL for connection to openEO cloud. Is it correct?
So you have a couple of backends. So openEO is a layer which works in a backend agnostic way. And a backend here is this computer which has data and processing capability. So we have the Copernicus one. If you take a look at the Getting Started notebook, there it has the URL. I can show it for the backend of the Copernicus data space ecosystem. So let's take a look. Let's go to Python here. Let's go to getting started. And here we see the openEO database Copernicus EU. So this is the backend which we're now using, being the Copernicus one, which hosts the Sentinel-2 data. The one you are referring to, the openEO.cloud, I think most likely we can see it here. It's a different backend. So it's another backend on which you can also use openEO, but it also has different data sets. Okay, even it's not even listed here. Here we use the federated one, but that's a Terrascope one. That's the Belgian platform that also has Sentinel data, but only, I think, for Europe for the last 2 years, maybe. So it's also one you can use, but that means that you need to make a Terrascope account instead of a CSE account. So probably now you run into an issue because you don't have a Terrascope account yet. And when you try to do your authentication, it's not working. I can see if I can.
Yeah,
Also,
I have both accounts, but
yeah.
I'm not sure why it's not working. But can you copy the another link, another URL for open
I think
Copernicus?
you're now using this one probably, yeah?
Yes,
It's
I'm using
openEO.cloud.
openEO Cloud. Yes.
Yeah, and then you end up here. That's the Terrascope one. I'll send the link to the one which we are using in this exercise in the getting started. So that's a data space ecosystem. So now that's a bit more experimental. In some of these notebooks, you'll see us refer to federated endpoint. What we actually want to do at the end is take all of this away for a user, that you have one link and we always use that link. And then as a user, you don't need to think on which backend am I going to use. I simply log in with openEO and it will figure out the best choice for me. But that's still something which is in production, on which we're working. So for now, typically we advise people to use the CDSE backend because it has the most processing capabilities and European-wise the most interesting data sets. Also take a look. I think we have some comments in the chat as well. The one from Megan I addressed, yeah. So Miraya, I think, Miriana, I think for you, the process graph looks great. Did you manage to run it and get the results? Let's see. No immediate response, but at least that looks good. Okay, I suggest we wait 5 more minutes to give a couple of people who ran into some issues some time to catch up. And then I'll go together with you through this exercise. And who knows, I might also run into something. Pejak, did you still have an issue? I see your hand is still raised in the call.
Yeah, no, it's working. Yeah.
Okay, perfect.
Yep.
I think we now also have a short coffee break planned. So after the coffee break, I think we can continue, and then I'll live go to the process as well, and you can follow along on how I would do it and get to the results. And we can even think on how could we then scale it up, what is multi-backend job manager.
I see you're still sharing your screen. Maybe.
Oh, okay.
Yeah.
Till what time is the actual coffee break, Lori?
Yeah, so the coffee break was going to be until 2:45, 3. So
Oh,
I would
okay.
say maybe we should take a break right now for like 10 minutes, 15 minutes, and then come back around, shall we say 10 to 3 or 5 to 3, something like that?
Perfect.
Okay.
Okay.
Okay, we'll see everybody then. Bye.
Okay, everyone. So I think now I'll guide you through a bit the solution. Let's see, might run into some issues myself. These will then also be interesting to try to resolve. So first, I think it's I can't find my diff. Question, it depends a bit on how you execute the openEO job. You can start a job which doesn't involve automatically downloading it. If you invoke execute batch, it would automatically normally download it as well. But you can always go to the Copernicus web editor. And I'll share my screen here. And then here you can see a list of all the jobs which you ran, which were finished. We can take a look, get some information about the job which we actually did. And then you can even download the output. So here I have this merged cube. I can download the netctf. So if you can't find it, you can try to get access to the CDSE web editor. And if you have a job which has an error, for instance here, I have an error in this job, we can also go to the job logs. So that's also very different if you work locally versus remotely. This job was a bit too old. I think the logs only remain there for 1 month probably. Let's see if I can find some logs still on this job. This is a bit different when working locally as remote. Programming locally, we're usually, if an error comes in, we see all the logs on our own PC. Here, of course, the actual processing as a Word occurs on a remote PC. And we save as much of those logs as we can, so you get quite a lot of information. So often you then first need to figure out, okay, what's actually going wrong? Now, the good thing is, if you have an error, you can actually try to get only the error messages and then take a look at the actual error messages of what's going on. Now, if you can't resolve it yourself in that way, what's also a nice resource, which I haven't introduced just yet. So if you go back to the ecosystem, and we go to support, we also have a community forum. And on the community forum, you see there are different topics. If something goes wrong in your Copernicus web browser, then you can post there questions about it. If you have something not working in your Jupyter Lab, but also in openEO. And so it's always interesting if then something goes wrong, know that from the openEO team, we also always have 1 or 2 people who are responsible for maintenance and responding. So this is, I think, a very relevant here one. I see a post a couple of days ago, again, on this backscatter collection, something which is going wrong. And then you can ask your question like, hey, this batch job failed for me with some error. What can I do? And then someone from our team would actually answer it. And here we see that on this backscatter collection, something is going wrong on the openEO. So then we provide an actual solution. And we can even provide a GitHub issue where you can then track once we actually have resolved the issue. So here you can get quite a lot of interaction with the openEO team as well. If something is not working for you or if something is not entirely clear. So then I think we can go into the exercise. And I'll try to change a bit this getting started notebook for the actual exercise and copy paste some stuff which we actually need. So the first step for us was to make this connection and to authenticate. In this case, we are here interested in using the Copernicus data space ecosystem. Let's do that. So import openEO, and we make our connection. I already had a token, so that was authenticated. If you see the status pending, this was one of the questions we also had, that you need to click through. You end up in the web browser login where you actually can log in. So in this case, we don't need these cells. We know which data we're going to use. Here, I'll simply use the box defined in this example for now. And let's take a look for an entire year. So we're going to take our Sentinel data, but we also want to calculate NDVI. So we need to know which bands do we actually want to use. I don't know it by heart. So what I do is I go to the community examples and I see, does any of these community examples, could they provide me any more information? So let's take a look. Some reduced dimension. What we can even do is we could also search here in getting started notebook, or I think in the load stack one, which I introduced. So in this load stack example, I know we were using the NDVI. So let's take a look at the Sentinel-2 data, which was loaded in. Oh, okay. I see we use band 4 and band 08. So let's skip this one. And we built our first cube. We can take a look how the cube looks like. So now I didn't filter on max cloud cover. I'm getting all possible observations. For a full year, that's going to be quite a lot of data. So let's browse a bit again between these different community examples. I'll go to the multiple jobs one. There I also got some nice inspiration. And I'm going to see how they loaded in their data. Yeah. Okay. So here I again see some Sentinel loading in. I see they're using a max cloud cover, EO cloud cover of 60%. So I think I'll simply copy this over. And then we can get it to work. So there we go. So let's take a look at how our process graph is looking now for S2 cube. Yep. So we get in our Sentinel-2 data. Oh, I was only interested in bands 02 and 04. I forgot. Oh, band 4 and band 08, right? So let's correct that. Okay. So then here we would have a cube now in which we have masked our clouds away, and this cube should only contain band 04 and band 08. What I'm going to do on this cube is, I'm going to calculate the NDVI, and well, look, GitHub Copilot is really smart in what I want it to do. So we can add this block and define an NDVI cube. Go. So now the change here is we added this additional block, which calculates the NDVI. Now, it might be that we're not 100% sure of how this NDVI works. So I can take a look at the underlying code. Because it is all open source, I can take a look at this defined openEO process. What I see here is takes in a near infrared band, takes in the red band, and some target band. So we can give as an optional parameter the name of the near band, and as an optional parameter the name of the red band. So there's near. It will get it from the metadata. Okay. So now my first band will be automatically the near band, and the second band will be the red band. I'm looking at Lori. Should I then use as a first band B08, or should I first use B04? Which one is the near infrared one? Okay. So then let's keep this one as our first entry, which is a near infrared. And let's use B08 as the red band.
Other way around.
It's going to be the other way around. Okay, great. So then we just toss them around. Oops. There we go. So now, first band, near infrared. The band I'll use is B08. The second one will be B04. So we weren't done yet with calculating the NDVI. Now for every time step in which we have data, we'll calculate the NDVI. But what we wanted to do is to calculate the temporal mean per month. So posit cube equals yips. Period month mean. Let's see if I did that correctly. I can go again and take a look at the open source code and try to read in this information on how it works. Calculate temporal period is one I want to use. I can give a period. Let's see. These are the periods which are supported. We have decade, year, tropical season, month, decade. So I know I want to use month. And then we also have a reducer. I see for parameter dimension is that the temporal dimension will be used for aggregation. So in this case, if the dimension is not set, it will simply use the temporal dimension. So that's fine for me. Okay, so period, that's the one we want to use. And what's wrong here? Okay, then we can see if this works well. Then we have aggregate temporal period. For now, we haven't done anything. What we still want to do is now save the result. So what we can do is we can add another node, one for saving. Let's take a look. Save result. Whoops. So we set the format to cloud optimized geotiffs, and we simply call this API.diff. And we call this our save cube. So far, nothing is happening. Oh, that's great. Something is wrong. datacube.saveResult got an unexpected keyword output file. That's great. I made a mistake. So let's take a look at the definition of save result. Oh, we can give it a format. Okay. Creative, that's fine. Let's see what happens then. Whoops. Or what I can also do if I find this information a bit too technical, I can take a look on how was it done in a different example. Let's take a look here. I see, yeah, save result. It only passed a format. Okay, great. So this should now work. Yeah, okay. Now we have a nice process graph. We get our Sentinel-2 data. We get our SCL layer. We're performing mask SCL dilation. We mask our data. We calculate the NDVI for every time step. Then we do our aggregate temporal period, and we save a result. Now, when I look at this process graph, there's one thing which I'm wondering is this computational efficient? Because in this case, I calculate the NDVI across all the time steps. So for now, I haven't done any temporal aggregation. So here I have a full year worth of data, which I'll all mask. I'll calculate the NVI, and then I combine this data together. What I could also do is calculate the NVI on my aggregate temporal. So we could also try maybe to swap these two around, and this could have an influence on, for instance, the total cost, because it would make the algorithm a bit more efficient. And that's something typically we try to do as an openEO data engineering team, to take a look at these process graphs, run them, test them, see can we improve them while maintaining the correct output. But let's now run it as is. With an eye on time, I'll keep a shorter temporal period of 3 months. And then the only thing we still need to do is execute our batch job. And then we can see if it actually runs. So that was a bit the exercise, to go a bit through the different notebooks and copy paste what you actually need. And I think that's also typical way of working. We try with openEO with these community examples to provide quite some workbooks with inspiration on how you can do things with openEO. So whenever there's a new feature, we will also create a new notebook on how you can use it. For very detailed information on these individual operations, if you want to know more on specific operations, or you want to know, hey, how can I do this? One resource is this community notebooks, and take a look on what's being offered there. But of course, the best documentation is on openEO.org. Here we list all our user information. We also here have some getting started, but we have a list, for instance, on all the various operations which you can do with openEO. And normally you can swap them and exchange them from order, and they should all work together with each other. And if it doesn't work, it's really nice to interact with us and to contact us, because that means that we actually have an opportunity to fix it. So let's see, in case of this aggregate temporal period, if we can, this is also a resample operation. We can take a look here. Then we get some information. What does resample cube spatial do? We can see we can provide the method on how we want to resample it, and it works on an openEO data cube. The standard method is near, but also all these other methods are supported. The input is a data cube. The output will also be a data cube. And here we'll list some information, but you see the openEO.org information is technical. And then in the community examples, we try to provide more workflow-based examples on how can you do things with openEO. And we try to make it easier to browse through them, to get to know them, to find actually a notebook which is relevant to you. So I think here, for instance, for NDVI, I see there's a notebook here on forest fires with NDVI. So we could have also taken a look here on forest fire notebook and see how do they do it, how do they work, and does this fit with my way of working. Then we could have seen, okay, they also give some spatial box and some spatial extent in Laplon. Great. This is something which I also need for loading in my data. So I can pass here my arguments. What I see here is, again, they load in some data. They get a couple of bands, B04, B08, also B12. Okay, that's interesting. We didn't use that one. And okay, they ran the NVI on this s2.precube. And then they downloaded this result as a TIFF file. So that's an interesting, and we can take a look at the notebook. How does the output then look like on what they have done? So here in this notebooks is really something to browse through to get some inspiration. And then if you want more detailed information, you can go to openeo.org and really get into the nitty-gritty details on the different things, on the actual way of working. Let's see if my job got finished. Yes, it did. Great. So here I now have a job. The job, it was for me now 4 credits. Let's see if I also downloaded my result. I actually need to go to this folder in which the notebook is hosted. So, whoops. Yep. So you see here, I didn't download the result, or did it? So I might have run into the same issue now as I think Megan, which is interesting, but I did add a save result node. So let's see if we can fix this. Okay, so here I can give an output file. So let's try this again. And we can do this again. And else we could also go to the web browser and download the result from there, but actually this should work. So curious to see if it's going to work now. Before I take a look if the result got downloaded, does this way of working raise any questions or any comments? Yeah, go ahead, Branko. Oh, wait, sorry, my headphones. So if I ignored anyone. Okay.
Thank you for presentation. And I just wanted to ask, can you show the graph, the processing graph that was made at the end?
Yeah.
I've also tried to make the same graph using openEO web editor, and it was quite more difficult than here because I couldn't connect the reduction process with the Sentinel-2 source. And here, if you click twice on if you show the graph, and if it's possible, maybe not now.
I can do so once the job has run out, because I need to have
when it finished.
So once the job has completed, I can show the process graph once more.
Then, if you could go inside the graph and just maybe give us more details regarding the elements inside the process.
Yeah, that's great. I'll log into the web editor. For me, it has been complaining today, so it might take a couple of minutes to get logged in. but I'll do so. And then we can go in a bit more detail on the actual process graph. Web editor. So logging in as we speak. Okay. Sorry, I think I forgot my password. So I'm requesting a new one. There we go. Also a live demo effect. Okay, so now I should be logged in. Okay, let me share my screen. There we go. Yep. Let's see if I can now log in. So, this is the web editor. Here I indeed can see all the jobs which I have been running in the past and their status. See, I have one job which is still running. This is a job which was finished. This is actually the example job which I ran. Here you can see the process graph. So the individual steps which I do is, it's also interesting, you can swap between the actual code of the process graph and the visualization. We can take a look at first getting Sentinel-2 data. If you click here in the right bottom, you get more information on this load collection operation as well. We can see the temporal interval which was used. We can see which bands which were loaded in. We can close this once more. We created an SEL dilation mask. So here you can use mask values which were used and the kernel sizes which were used. These are some standard input parameters. I masked the data, calculated NDVI, then did the aggregate temporal period by month with a mean reducer, save result, and I executed my job. And if I take a look in the web browser as well, I can take a look at the logs. In this case, I wouldn't, or I normally shouldn't have an error log because the job finished correctly. So that doesn't make too much sense to check the error logs, but either way, we could see were there any warnings, anything which might have gone wrong. In this case, the job was finished, so we don't need to delve too deeply into the logs. From this previous job, we could also download the output here if you want. But I think my job now was finished. So I would hope actually that it's downloading itself. For some reason, it's not working. So I think we found here a live bug, which I need to spend some time on. Here it goes. What went wrong? Can't use download file with multiple assets. Okay, should use download files. Okay. I think maybe the issue is that we're saving as a GeoTIFF instead of a netcdf or so. Because a GeoTIFF only has 3 dimensions and our output will be 4-dimensional. Yeah, either way, we could download it from the web browser. I think I have it here. Where is it? Downloads. Open file. Nope. We have it here. Yes. Open the file. I open it. Yep. So then we see we get an image. I think in this case, probably because we have, I think what might have gone wrong here in my assumption was that it automatically downloads all the GeoTIFF files. Probably in this case, it's better to save it as a netcdf. So netcdf is a data format for 4-dimensional data. So since we have multiple time steps, in spatial dimensions, and band information on NDVI, might be that the GeoTIFF format is complaining, or can be simply be that in the viewer we now see the first temporal slot, or only the first timestamp. I can try to open it with raster IO to get a bit more information. But that was, I think, the crux of this first exercise. Then I see we also had a question about this cubes and clouds. So what I'm going to do is head over to the Cubes and Clouds platform to showcase a bit what's being covered there.
One thing about those data formats. So if we use netcdf, then we can use rasterio and directly open it as a 4-dimensional NumPy matrix.
Yeah.
Okay. I had a problem because previously I saved results as a TIFF, and I was expecting let's say several NDVI layers, one per each month of aggregation.
Yep.
And at the end, I got only one slice. Is that because TIFF format only works with 3-dimensional data? So I got like longitude, latitude, and I got just like NDVI, like single depth channel, and that was it. So I lost other layers.
I'll check the file actually, which I got from my output, because I fully agree with you that actually this GeoTIFF should be able to have multiple time steps. So at this point, I also need to figure out what here is going wrong. I'll probably give a response tomorrow. So I'll take some time this evening to figure out what's happening here. Because if I take a look at the, oh, am I still showing my screen? No. Yeah, I'll figure out what's happening here, and I'll give a response, I think, tomorrow. But if you go to the web editor, and I'll share my screen. So what you see, I went to this job. This was a finished job. You see the output has multiple assets. So I now ran it for 3 timestamps. So you can download each individual monthly composite. So I have one for the month of May, June, and August, and I can download all of them separately. So the openEO workflow is giving all the outputs, but it's saving each temporal asset as a single cloud-optimized geotiff. So I'll need to do some digging to figure out if this geotiff format actually supports multi-temporal resolution. I know NetCDF does it. I'm not sure if cloud-optimized geotiff supports it. But either way, from openEO, you can get all your outputs, but there might be in separate geotiffs. And I'll first jump maybe to the cubes and clouds. So I think I can do this live. And if not, it will be interesting. So cubes and clouds. So it is massive MOOC. Here we can see a nice summary of what it will actually cover. So you get some information on how to access ESA and other data. This is really the data on CDC. And it will also give some information on how we can process it. Now, let's try to find the EO College. I should already have an account, but it doesn't know me, so I think I still need to enroll. Let's see, log in. Nope. Okay, so what you need to do is you need to create an account. Yep. There we go. Not a robot. Oh, motorcycle. Not man with fake face. Let's create an account. If I got it. Hope this is now fine. No clue. Yeah, either way, what we can also do, I think if you go to GitHub, EO, Cubes and Clouds GitHub, and Clouds GitHub. I think this is actually the more interesting part. So you have the EO College, and there they actually have lessons. And so you can watch movies on the different subjects. And all these movies also come with specific exercises. What I usually, if you have some coding experience or you have a lot of geospatial experience, I often simply refer to the GitHub. I can share this link also in the chat. Because the course does take 40 hours, which can be quite time intensive. So what I did is I simply went to their GitHub and I ran through their notebooks. And then you can see, for instance, here, there's an MD file. So here we can simply read through some of these notebooks, gives us some information, and you'll see some figures popping up again, which I also used in my presentation on what is now this data cube, how is it structured, and get some more information. We even have some links here to the videos where they explain it. And what's really interesting is it also comes with some exercises. I think here in the data sharing, for instance, we see a folder with exercises. And we can take a look at the notebook. So what you'll see here is a notebook where they're also using openEO. So that's always interesting to see. In this case, they're again using the Copernicus data space ecosystem. And then you again can go through a notebook. In this case, they use another library, leaf map, to find an area of interest and to create a bounding box. So they have some utility functions. They create a temporal extent. And they created a function to, I think here, what are they doing? Calculate SEA. So this is also both based on some openEO code. You see here again a reduced dimension popping up. So, and how you execute the job. So this is, I think, the last exercise. It kind of builds up. We also have some simple exercises, I think, in data processing. here, for instance, you'll see some exercises really tailored to these different processes, which I showed. This here, an exercise on loading a data cube, calculating the NDSI. So here they define their band math themselves. They say, hey, this is going to be my green band. This is my sphere band. I want to do this type of band math. I do want to do some rescaling as well. They perform some cloud masking. And then let's see, in the end, they will most likely also execute this job. Let's see if you find it here. Yeah, they save it here as a JSON file. They create a job and they say, well, now start and wait. So besides the community notebooks, here there are also some exercises which you can do. So this can also be a great starting point, especially if you don't have a lot of experience and you don't know geospatial processing as much, then it can be nice to run through the notebooks one by one and get a bit familiar with them. So that's a really nice resource, and I'll share it here in the chat. So that's for the question from Milos. Then we don't have any direct connection to QGIS just yet via plugin. Not sure if it's on our roadmap. Of course, our output is, let's say, QGIS compatible, because we always, you're able to write with netCDFs or geotiffs, which you can read in QGIS. So often it's simple that you run your openEO job, you download your result, and then you visualize it in QGIS. So not integrated, but you can combine these two tools efficiently together as well. Were there any other questions or comments at this point?
One conceptual question. I saw your computation graph, and I think that you have two steps that are not necessary based on task specification about mask and dilatation. So are they necessary or they are not? Because I haven't included them. And what is their purpose, if you can be more precise?
So yeah, that's a really nice question. So the core idea of including this mask, I'll go to the code maybe. So whoops. See. So we could perfectly remove this step and still get a valid output. And so this is a step where we mask our S2 cube with a cloud mask. You can indeed remove it. Now, the core idea is that when we want to calculate the NDVI, calculating it on pixels which don't show actually any results but show clouds is not valuable. It doesn't either way contain any results. So by here doing explicit cloud masking, we set these values to none, and openEO is smart enough to know, okay, I don't need to process these pixels. And in this way, your process should become faster and more efficient because you're going to process a lower amount of data. So that's why I here use the cloud masking to limit the amount of processing. And to make that a bit more visual, we can go to the Copernicus web browser.
Okay, but when we were loading Sentinel-2 data, we had parameters something like cloud cover, and we set a value to 50. And what's the difference between that way, where we just had one more line where we specify a threshold, and this way with the masking?
Yeah, that's an excellent question. So if we take a look at, for instance, Sentinel-2, we can take a look here. Let's say we're looking at this Sentinel-2 tile. So what openEO does is for your area of interest, it's going to chunk it in small blocks and it's going to process them individually. Now, let's go to maybe a more cloudy period. Let's go to January and show some dates. Okay, here. So with setting this max value, for instance, in this area, if I say max 60%, it's a very cloudy day. So what I'll do is I'll just throw away this entire timestamp when you set it to max 10% or so. However, you can see that here there's a small gap in which there is valuable data, potentially. And the difference between these two steps, if I go to the code again, you have two options. One thing which we can do is either we can say, we can put a very low limit and we can say, well, only use data for which on average for the entire area which I'm loading in, the cloud cover is maximally 10%. And then I'll only keep those timestamps for my processing with maximal 10% of cloud cover. So if I go here to the web browser again, and I set it here to, it's 10%, what I'll do then, if I process the month of January, is I'll only keep this day, for instance, because here for my area of interest, the cloud, there weren't that many clouds, so I'm keeping this data. Looks like the web browser is a bit slow today. Data is still loading, but if we take a look at the agenda, what happens is I only keep these days, which are marked here in light gray, for my processing. Now, however, it can be that on one of these cloudy days, there's still useful data because your max 10% of cloud cover, your max 10% of, can still contain some interesting data. So if you now set it a bit higher, we'll get more visualizations because we've increased the threshold, we get some more dates, we can take a look at this day, and I hope that the web browser will catch on. So I've now set it to 60%, that's the alternative. So the first one was set it really low, you don't get a lot of input data. The second option is set it high, in this case 60%. Now you'll also read in these type of data sets, which do contain really a lot of clouds. Now, calculating NDVI on these pixels, which are actually covered by clouds, doesn't make any sense. You can do it, but it doesn't make any sense. So what we'll then do is we add a process which will mask away this entire clouded area and set these values here to none. And then I'll only keep this small bit of my area of interest and, for instance, this small bit. And that means that even though it was cloudy, I can still get some valuable information of that small part of my tile which wasn't covered in cloud. So I hope that somewhat explains the difference, as either you set a very low threshold and say, well, I'm going to be very nitpicky in keeping only days where I don't have a lot of cloud cover. You can take a look at one of these days. If it even loads in any data. Come on. No, it's not 10%. So no, this seems to be not responding as fast as I would hope. So instead of looking in January, okay, data is still loading. So either we set it very low and we only keep timestamps of very clear days, such as ones we should expect, for instance, somewhere near June. Let's take a look. 5th. Okay, let's load the data. Then we'll calculate NDVI. I think here we have some data loaded in on these pixels. Very nice. We didn't have any clouds that day. Or we set it much higher, so we only have So we not only have these very nice days, but we also have days which did contain on average some clouds, but we remove the pixels which contain the clouds and also process the pixels which could still be good within that observation. So I understand it's a bit interpolated and it's a bit mixed. We at VITO usually prefer to use as much data as we can. So even when the observation was cloudy, we still want to use information in the pixels which weren't cloudy. That's why we prefer to make use of this SCL dilation mask. I see a question from Branko.
Just related to what you were talking about, if you can show the code just for a second.
Yep.
Does it mean that the predefined function NDVI is actually aware of non-values? And in the case that we wanted to manually write the formula for the index, that we should take care of non-values in the cube. So
in this case, the openEO process is going to be aware. So openEO is smart that way. It does realize that it doesn't need to process mask data. It can be if you load in data